Welcome. Today, we're opening up the toolbox for one of the most popular programming languages out there, Python. We're going to dive in and see exactly how it takes all that messy, raw information and organizes it into something, actually powerful and useful. Let's get right into it.
But first, I've got a question for you. Have you ever stopped to think about how your music app remembers all your playlists? Or how your banking app keeps perfect track of every single transaction? I mean, really, how does any software manage all that data?
Well, believe it or not, the answer is actually pretty simple at its core. It really all just comes down to choosing the right tool for the job. And in programming, we call these tools data structures. Today, we're going to explore the essential ones in Python's toolbox.
So here's what's on deck. We'll kick things off by comparing lists and tuples. Then we'll dive into the power of dictionaries, figure out what makes sets so unique, and wrap it all up by learning how to pick the perfect tool for any situation. Sound good?
Okay, first up, we have what I like to call the dynamic duo, lists and tuples. Now, at first glance, they look almost identical, right? They both store a bunch of items in a specific order. But there's one tiny, critical difference that changes absolutely everything.
So let's start with the list. First, it's ordered. The items stay exactly where you put them. It also lets you have duplicates, no problem. But the most important thing here, the key word, is mutable. That just means it's changeable. It's kind of like your shopping list. You can add stuff, cross things off, change your mind. It's made to be messed with.
And now let's meet its partner, the tuple. It's also ordered. And, yep, it allows duplicates too. But here's the big twist. It's immutable. Once you make a tuple, that's it. It's set in stone. You can't change it. Think about it like a set of GPS coordinates for a landmark. Those coordinates are fixed. They're not going to change.
So that's really the heart of it, right? Mutable versus immutable. A list gives you all the flexibility to change things up. A tuple, on the other hand, gives you a guarantee of stability. It is a locked, totally unchangeable sequence of data.
Now you might be sitting there thinking, wait a minute, why would I ever want something I can't change? And that's a great question. Well, this is where it gets really interesting. Because a tuple can't change, Python can do some clever stuff behind the scenes, some internal optimizations. That unchangeable nature, it actually has a secret advantage.
And trust me, that stability pays off in a big way, especially when you're dealing with tons of information. See, tuples take up less memory, and they're created way faster than lists. Just look at this data. Making 1 million tuples can be something like 8 times faster. When you're building apps that handle massive data sets, that little difference adds up to a huge performance boost. So here's the takeaway. If your data isn't going to change, a tuple is almost always the faster, more efficient choice.
Okay, so far we've been looking at tools that keep things in a neat sequence. But what if you don't care about the order at all? What if you just need to find something and find it fast? Well, for that job, we've got our next tool, the dictionary, and it's the ultimate lookup tool in our toolbox.
So a dictionary doesn't store things in a line. Instead, it works with something called key-value pairs. Basically, every piece of information, the value, gets a unique label, which we call a key. And just like a list, dictionaries are mutable, so you can add, change, or get rid of these pairs whenever you want.
Here's the perfect way to think about it. It's just like a contact in your phone. You don't scroll through hundreds of names one by one, right? No way. You just type in the name, that's the key, and boom, their info, the value, pops up instantly. So here, the key name points right to the value max, and the key age points to 28. It's a super direct link.
And honestly, that key value structure, that's the dictionary's superpower. Forget searching through a long list one item at a time. With a dictionary, you go straight to the information you need. As long as you have the key, finding the value is incredibly, almost instantly fast. And it doesn't matter how huge the dictionary gets.
All right, we're on to the final tool in our basic toolbox, and this one is called the set. Now, a set has one very specific, very powerful purpose that makes it totally different from everything else we've looked at so far.
Okay, so a set is unordered and it's mutable, but here is its one single defining feature. It absolutely, positively does not allow duplicate elements. If you try to add something that's already in there, the set just ignores it. Simple as that.
So the number one job of a set is to enforce uniqueness. It's perfect if you, say, want to count how many unique visitors came to your website. And because it's built for this, it's also lightning fast at checking if something is in the collection. Just answering a simple yes or no to the question, hey, is this item in here? Sets are also awesome for comparing two groups of things to see what they share.
A really simple way to picture it is like a collection of unique trading cards. You can't have two of the exact same card in your binder, right? Every single one has to be distinct. That's a set.
So there you have it, the 4 fundamental tools in Python's data toolbox. Now, let's bring it all home and create a super simple guide for choosing the right one for your project.
Think of this as your cheat sheet. Need an ordered collection that's going to change? Go for a list. Got ordered data that should never change and you want a speed boost? That's a job for a tuple. Need to look stuff up with the unique ID, like a contact list? The dictionary is your best friend for sure. And finally, if you just need to make sure everything is unique or quickly check if something exists, you're going to want to reach for a set.
And in the end, it all comes back to that main idea we started with. There's no single best tool here. Just like in a real toolbox, right? A hammer is perfect for nails, but it's awful for screws. The real key is to understand the job you're trying to do, and then pick the tool that was designed specifically for that purpose.
So, that's our deep dive into Python's core data toolbox. These 4 structures might seem pretty simple on their own, but they are literally the fundamental building blocks of our entire digital world. And that leaves us with one final thought. Every complex app, every website you use every single day is just built by combining these simple tools in new and creative ways. Which makes you wonder, right? What other incredible digital worlds can be built with just a few simple building blocks?